Hey guys, welcome back to the channel. In this video we'll be talking about the fundamental theorem of calculus and how we use it to problem solve. And we're mainly talking about the first part. The second part, it means a whole separate portion of this. This is technically considered integration even though we're taking a derivative. So let's just hop right into it, okay? So the problem we're trying to solve is find the derivative of the function h of x when h of x is equal to the integral of ln of t when it's evaluated from 1 to e to the x dt. And so this looks really impossible. This is really intimidating, especially on the AP Calculus exam, or if I saw this on the exam, I'd be really intimidated. So the way we do this is we apply the fundamental theorem of calculus, or in common terms, it's called FTC. Okay, and so we use the first part of the fundamental theorem of calculus, and what it means, essentially in a nutshell, summarized in this paragraph here that I wrote out for you guys. As long as we have a continuous function in this, as long as in here we have a continuous function, the derivative undoes the derivative undoes the integral, and vice versa. So derivative undoes integral and vice versa. All right, but they're not. But you cannot say they're inverses of each other, because that's not the case. And I'll actually go into a proof of why that's the case. If you guys want me to do that, then let me know in the comments down below. But okay, so pretty much to write it out, we say, okay, well, if we let g of x be a function and it's continuous and it's equal to this integral of the integral of a to x of f of t to which is evaluated from a to x with respect to time, well, as long as f is continuous, we could take the derivative of g and say it's equal to the functional value at x. So you could really think about it as us plugging f into x, or x into t, x into this f of t function here, and saying it's the derivative. All right, now that works in a lot of cases. All right, but there's also one more step we do. We also take the derivative of this piece here. So writing it out. So to solve problems such as these up here, we take the derivative of the upper limit x. Okay, and so we take its derivative, which is d dx over d dx of x, and then we plug in x into f. And so doing the problem this way. Sorry guys. Okay, so if we let so h of x equal the integral of 1 to e to the x ln dt. Well, to derive it, following the formula again, we plug in e to the x into ln of t, and then take the derivative of e to the x. All right, the derivative of e to the x is e to the x, and also by the laws of log, we take out x, and so because x is exponent, we could move it down. So x times ln of e, and we know ln of e is 1. So the derivative is equal to x e to the x. With that being said, guys, that's all the time we have today. We'll see you next time.